Hello, it's the end of the month, so it's time for another Incus monthly release. This time around, we're looking at Incus 6.10. I'm Stefan Gruber, I'm one of the maintainers of Incus, and let's go through what's new in this release. Now, it being the February 2025 release, it's slightly less busy as far as release content goes. That's because we're both looking at the shortest month of the year, and also because early February usually means travel to Europe for FOSDEM and for some other events, which easily takes out basically a week of development time. So, not the busiest release we've had, but still quite a few pretty exciting features in there, the vast majority of which have been contributed by new contributors to the project. So it's great to see more people contributing, adding new features, and picking up a bunch of the feature suggestions that we have. All right, enough said, let's go look at the features. So the first one is an extension to our ACME, which most people understand as Let's Encrypt, support within Incus. So up until now, we supported the HTTP 01 validation challenge, which effectively requires your Incus server to not only be available over the network, but also to have a proxy server that handles HTTP to HTTPS traffic redirection. Once you had that in place, you could turn on the ACME configuration options within the Incus server config and then get a certificate. That works fine, but it's kind of painful for individual servers that might not have a reverse proxy or anything in front to handle the HTTP traffic. It's also annoying for anyone running behind a firewall in an air-gapped environment or something like that. So with this release, we now have support for the DNS-01 challenge, which you can then configure with a number of different providers. So we're using the standard Go implementation of DNS-01 challenge, which is the same as is used in some of the other load balancers and that kind of thing. So very wide support for different providers. In the example here, we're using Cloudflare and just passing in the Cloudflare credentials through. So now with that, you can get a valid certificate on your Incus server without it needing to be directly exposed to the network. You just need your DNS provider or DNS solution to be supported by the Go ACME package effectively, and then you get to just configure it and you get a valid certificate out of it. So that works pretty well. Next up, also coming from a community member, is support for API-wide filtering. So up until now, you could do server-side filtering of instances, storage volumes, and images. That has now been expanded to allowing filtering on everything. So any API endpoint that gets you a collection of stuff, so like a list of URLs or just a list of objects, now supports the filter parameter and lets you do server-side filtering directly. The command line client on our side does not currently make use of that. It uses it for instance list, but not even for everything within the instance list yet. But it's something we are gonna see a bunch of improvements probably over the next few releases to start using more the server-side filtering feature. Next up, we've got support for SMBIOS type 11 data provisioning. So on x86 and on ARM, which both use effectively ACPI with DMI tables, it's possible to provide provisioning / seeding data to the guest by specifying effectively a bunch of key values inside of that SMBIOS type 11 table. When you do that, it's available through the kernel with files within the sys file system, but it's also picked up directly by systemd as credentials that can then be read within systemd units and be made use of that way. So here there's just like a simple example that I'll repeat afterwards, but it effectively sets a systemd credential foo equals bar, and then you can ask systemd for that credential and you get it back. And it does that by just passing it through that BIOS table instead of having to use like an agent that uses the network or VSOC or a serial device or any of the other usual tricks to get data into a VM. So that's pretty useful. The next one, which is going to be useful for some very specific users, and they probably know who they are, and hopefully completely invisible for everyone else, is that we now support IOMMUs within the VMs. So we've got an IOMMU controller that uses VirtaU IOMMU. So not every single OS and guest will necessarily understand how that works yet, but for anything modern that supports VirtaU IOMMU, you now get proper IOMMU groups for every single PCIe device, which is particularly useful when you look at doing things like device pass-through, and you want those IOMMU groups to be properly set up, either to then pass them through one layer further if you're doing nested VMs, or just for security by having potentially having the memory be properly segmented between groups. So that's now around. There's no option that needs to be done to get it. It's just there by default. Next up, for those using specifically the rooted type network interfaces, we now support tying those to a VRF. That's another contribution from a community member. So if you're using multiple VRFs, so virtual routing and forwarding devices within your Linux system, now you can attach specific containers to specific VRFs using the VRF property on the rooted NIC. Next is another improvement to the Preseed file used to initialize an Incus server. So I say, so this is like not the first improvement we've done around that over the past few releases, also coming from a community member. So just trying to kind of fill in some of the gaps and make it more general encompassing of everything we can do with Incus. So now it's just adding support for a project key within a profile entry. So when you initialize Incus, you can now feed it a list of projects you want to create, and then the profiles you want to see created within those projects with their configuration. And lastly on the list is support for LZ4 for backups and images. So basically everywhere you're dealing with tarballs, you can now have them be compressed using LZ4 instead of the default of gzip or occasionally a default of XZ itself, kind of depending on the use case. I think we usually do XZ for images and we do GZ for backups, but that can be always overridden on the command line, and now LZ4 is also supported. Okay, so let's do a quick demo of as many of those as we can, which is not going to be all of them. So the first one for the DNS-01, I'm not going to show on screen, because if I did, then that would be effectively the same as this example, except with valid credentials, which I would then need to go and cancel immediately after recording this video so that nobody tries to abuse the account. But basically that configuration is functional. So if you're using something like Cloudflare, you can use that for your main account API key. If you're using Cloudflare and you want a per zone or per DNS API key, then it's a bit different. You need to create that specific key, pass it as, I think it's Cloudflare DNS API token, it's named the variable in that case, and pass it through that way. You can actually get all of those pretty easily. I think if we look for Lego providers, maybe. Yeah, so Indigo, ACME, Lego, DNS index, then you've got all of the different providers that are supported for DNS, which is quite a lot of them. And so if we wanted to say, look, in this case, that's the Cloudflare one, I guess that's probably points to the right place. Yeah, there we go. And it gives you the environment variable names and of the different options to set. So in this case, we had Cloudflare API key and Cloudflare email. But if you were doing that DNS API token, you'd use this guy instead of the others. And anyway, yeah, it very much depends on what provider you're using. The example uses Cloudflare, but you can use a lot of other options, as you can see here. So that one I'm going to skip for the demo, since otherwise that would just be, it's not particularly interesting to see. It just gets you a valid certificate and would be tricky because of credentials. So the next one is API-wide filtering support. So that one I can show. So by default, if you just do Incus list, Or now if I want just a kernel one, Incus list kernel. This is just filtering on the full list being returned. But if we look at something like status running, and we go look at the request being made, need to scroll a bunch. And then we're gonna see, actually that's, it should be after that. Yeah, there we go. Okay, so that's the get request, and we can see here filter status egg running. So that's how that's done, and that's on the instances which already supported it. So if we just want to take a look, we could do something like this: filter name egg kernel test, and now it filters it for just this one thing. So that's what already was in place. Same thing for images, same thing for storage volumes, and it's just been expanded to everything else. So if we go look at, say, the storage pools list now, and I wanted to filter that, we can do it server-side instantly that way. In this case, I'm filtering on the name. Doesn't need to be. You can filter on properties. You can filter on other things. Neither of those have a description, so let's do surf, and I'll just let's put a description saying remote, for example, and we wanted to filter on that. There we go. So yeah, it lets you filter on different properties. You can even go quite a bit deeper, I think, for instances with support filtering on the devices and a bunch of other things. There is a documentation linked in the announcement for more details on kind of how that works. It also can do more than just a simple equal filter. You can do some basic logic as well. All right. Next up is SMBIOS 11. So I'm going to literally just use the exact same example I've put in the announcement. But so if we take that, that takes a new VM, call it D12, uses the Debian 12 VM image, and we pass in through SMBIOS 11, we set the config key prefix IO systemd credential, and then within that we set the variable foo to bar. And if we start that, then we just need to give it a little bit for it to boot up. There we go. And you can ask systemd directly for that credential since it's passed that way. But you can also, I'm trying to remember the exact path. It's probably through DMI. Sure, ID. Is it in there? Doesn't look like it's in there. Let me actually just look at the link. So there's a link in the announcement for the SMBIOS feature, and that actually says where it usually lands, which is sys firmware DMI entries 11. Okay, so sys firmware DMI entries and then 11. You can see there's one record within the table 11, and the raw value would then show, in this case, it's not very readable. Hold on, do it that way. There we go. IO systemd credential foo bar. So that's how it's passed through. You can pass multiple configuration keys and provide more information that way. There's some more details in that page that's linked, which can explain the general concept. In my example, I used the IO systemd credential to just pass in this case, a clear text value, but you can also use binary and then pass in effectively a base64 encoded value instead that gets decoded by systemd. And there's some more options like if you're using the systemd stub, so the UEFI stub for systemd, you can pass in command line arguments, and same thing if you're using systemd boot. So just pretty convenient way to pass in data without needing a custom agent or anything in there. Next up is IOMMU. So this one we can literally do from the exact same VM. If we go look at the boot, this one is an older OS. It's an older version of Debian, which is running kernel 6.1. So it doesn't show a whole lot. It just says like, oh, okay, well, couldn't do AMD IOMMU because it's not running on physical machine. And it doesn't know how to do the virtual IOMMU because it's too old, basically. So if we go and blow away that VM and say, if if I do Debian 13, that should probably work fine. So that's the upcoming Debian release. Gonna give it a few seconds to boot up here. Should probably be fine now, not quite. There we go. Okay, so that's a more recent kernel. And it still doesn't have the IOMMU in this kernel. That's interesting. Actually, let me check. I did still with the Ubuntu kernel recently, which does, but it's quite possible that we're missing. Yep, the IOMMU is not set in the Debian kernel, so I might need to ask someone to try and fix that. That'd be nice. Okay, fine. So I'm gonna test it with Ubuntu 24.04, which I know that one does have the needed driver. And so there are effectively multiple ways to do the IOMMU stuff. An older way was to simulate the Intel IOMMU driver. That gets a bit weird when you're running on AMD with like an Intel IOMMU implementation. It's not ideal. I also don't generally like QEMU faking real hardware. Whenever a VATIO option is available, I prefer that we use that, which is why we're doing VATIO IOMMU, but apparently not all distros are supporting that quite yet. So there we go. This is on Ubuntu 24.04, so this one we can see all of the IOMMU groups come in. One thing that's interesting, that's probably not obvious to anyone, but so this one is on x86, and the one in the enhancement, which actually looks basically identical, minus the AGP stuff Intel thing here. This was on ARM. So just to show that you effectively get the exact same behavior on ARM64, it just works as well. So anyway, if you need IOMMU groups to be set up properly, just make sure you're running a recent Linux kernel, or at least one that has the VATIO IOMMU driver enabled. Next up are VRFs, and it's not a feature I particularly use, so let's see. I kind of know how it works, but just see if I can actually set it up for a quick demo. So first we need to actually create a VRF. I think it's is it type VRF? Foo table 1, 2, 3, something like that. No, it's not. Is it VRF add? VRF add? No. Is there an IP VRF? Yes, there is. Okay. But that's just to list them. Okay. Let me just figure it out from our examples in the tests. IP link add. Okay, so I was pretty close. IP link add, but then it's the name. Yeah, I never get the argument order correct in IP route. Then type VRF, then the table. Sure. Okay, so now we've got a VRF, which presumably means that this one shows it. Yep, there we go. So now we have VRF. It's tied to a new device called Foo. So if we look at the linked list, we actually do see it here. And it's actually not up, so we should fix that. Set the Foo up. Okay. Show table 1, 2, 3. So there's effectively a tied up table as well, which is currently completely empty, which is table 1, 2, 3. But if we create a container, attach it with a rooted NIC to that VRF, presumably that's gonna work. So let's try that. So just create a basic container. And then I'm gonna override its network device. And I've not used the routed NICs in quite a while. So the basics obviously is we need that, but I don't think it's quite that simple. I'm reasonably sure that rooted NICs also need IP addressing. So let me just look up the doc here. So if we look at rooted NIC, show IP address, yeah, so obviously we need that, but IPv4 address, IPv4 gateway, I guess is the minimum, and that should do it. I can try that. Let's try it. So IPv4.address 123.123, something like that. Actually, that might just be sufficient because it will put a static root but uses a a point-to-point device on the host. So that might be good enough. Invalid value, I think not. Okay, so it wants just the address, fine. Okay, let's try that. Okay, so that starts. Not sure it's gonna work, but that starts. And now, yeah, there we go. So in the VRF, we can see the specific address was put in place. What that actually means is if I try to ping this, that shouldn't work. Yes, because when I look for the gateway or the address, yeah, the next hop to access that IP address, I'm just looking in the default VRF, not in that new VRF, so I don't see it. I don't know if it does VRF lookup. It does, okay. So if I was in the full VRF, then I would have the correct path for that. And I think I saw some command in IPVRF that lets you do exec. Yes. Okay. So presumably if I do IPVRF exec, foo, ping 10.123.123.100, then that should go the right way. Okay, but it doesn't. That's interesting. Not too sure how that works actually. So maybe the IPVRF exec stuff doesn't work the way I thought it did. Or running IP route that way doesn't actually do what I want. Anyway, ping didn't work, which makes actually sense. That's because the container itself doesn't magically get configured. So we still need to actually bring up the interface and just check let's add the actual IP that we want, which is 10.123.123.100. So just one IP address, and we want that on 0. And also didn't put in a route. It's probably more than you ever wanted to see about any of that stuff, but okay, so the host side IP address is this. So just default via this dev. We need to directly attach to the link and then put as default. Okay. Okay. Okay, it can't make it any further because it's still within the VRF, and the VRF doesn't have a default gateway. But maybe ping works now. Yep, it does. Cool. All right. Again, probably way more than anyone wanted to really see about this stuff, but that's how that works. So if you're using VRFs, it works as expected. I can now delete this stuff and we'll be fine. Cool. So that's the VRF support. Next is the preceding. I'm not gonna deploy a new Incus just to show that, but kind of similar to last time when we added new features. There's an example in the documentation which does show what it looks like when you've got multiple profiles in here. And effectively, if you do want it to, if you want a specific profile to be applied to a specific project, then you put the project key on the profile with the name of the project, and it just works. And lastly, is support for LZ4. I don't know if I actually have LZ4 configured on my machine. I do, cool. That would be an easy one then. You just clean things up a bit there. And if we just do a basic container again. So if I export this stuff, actually have already some stuff. Clean down it. Okay, so I've got a container, and if I just export it with the default options, you get a tar-gz tarball. Now you can go at, I think it's compression or compression algorithm. I'm not completely sure, but let's try compression for now. LZ4, yeah, that worked. And now we've got the same thing as LZ4 instead. So that works basically as expected. If for the same thing for the import, if I just delete the instance and then I import the LZ4 version of it, there we go. And then we can start it back up. And the instance is back. So works exactly as expected. As mentioned, we support it for both, for instances, for for storage volumes, and also for images. So during export, you can specify the compression algorithm there. Same thing if you do a storage volume export, it also is supported here. And for images, that happens during publishing time. So if you do publish also has compression that you can set at that time when the image gets created. So that's your different options for that, and LZ4 is effectively now supported alongside a whole bunch of other things. Like we support SquashFS, we support GZ, BZ2, XZ, I think some other various variants of LZMA. We support the standard, I think, too. So basically, the usual compression options are all supported. And if you see one that you're commonly using that is not supported, let us know. It's pretty easy. We just need to add the right archive magic header and then the right decompressor in our logic, and then it just works. And that's it for Incus 610. So packages are up already in the Zabli repo. I expect that the other distros are gonna pick it up over the next few weeks as usual. If you've got any problems with it or any questions, please go to our community forum. That's usually the best way to handle that. Bug reports can go directly on GitHub, but it's usually best to start a chat on the forum, get as much data as possible there, and then file an issue afterwards. Otherwise, feel free to leave any comments and questions down below in the comment section, and I'll see you in the next one. Bye.